Hey guys, so in this next video we're going to cover a summing amplifier, and all this does is it sums three discrete voltages into one. So I'll just quickly show you the architecture of this circuit. We're basically going to have three different voltage sources, and they're going to be connected through three different resistances. And then we're going to tie them all to our negative terminal of our op amp. Okay, we'll say this is R1 and this is V1, R2, R3, V2, V3, and all of these are connected to ground. And then we'll have V out right here. And there's one other step, and that's very similar to what we've been seeing, and that's we're going to tie the negative terminal through a resistor to the output named RF. We can say, let's define some more terms here. We can say the current flowing through here is going to be IF. As we already know, this I minus is going to be equal to 0. Let's see if I can draw this a little better. Basically, at this point, we have the virtual ground effect that we've been talking about. And then we'll define I1, I2, and I3 as flowing from these three sources into our main junction. All right. So we can define IF as being equal to I1 plus I2 plus I3. And we know I minus is equal to 0, so we're just not even going to include that one. So we can redefine IF as VO divided by RF. And we can do that because of this virtual ground here. So we're just basically looking at this node at this point going all the way to this node. And if we look at those two nodes, one is 0, even though it's a virtual ground, we can say that VO is just equal to RF. All right, we'll set that equal to I1, and we can define I1 as just V1 divided by R1. And we can do that because of that virtual ground once again. Next step is going to be pretty much the same thing, V2, R2, and V3, R3. Yeah, so actually I'm going to make this a little lighter. It's a little harder to see. Yeah, so basically then we can define VO. We'll say VO is going to be equal to minus RF divided by R1 V1 plus minus RF. Gosh, I can't write again. RF over R2 V2. And then we have minus RF R3 V3. So there you can see V out is the sum of V1, V2, V3, and we're basically scaled by these resistance values.